to Biology webinar. My name is Daniel, and today I'm going to be your host. We have, for today, we are planning two sections. So first will be our presentation about the software, and the second session will be a Q&A. And while we will do a presentation, feel free to post your questions in our chat, where my colleagues will be able to pick your questions and answer that while they can. So just to quickly reiterate what we are about here. So Biology is an innovations development company with the goal of creation and implementation of the new waste management technologies that meet the requirements of modern city environment and smart cities. Our first project was SmartCity bin, smart waste bin. It's a technologically sophisticated waste container with a wide range of benefits over traditional bins. And we discovered this device in detail during our previous webinar. Today, we'd like to present the software part of our solution. It's called Biology Smart City Management. So it's a proprietary SaaS system, and which enables real-time collection of various data from containers such as location, fullness level, battery charge, environmental parameters, etc. System operator monitors and controls waste collection processes and sends truck drivers to trash pickup routes as needed. Drivers receive routes via a mobile app. We are going to see that all today. All data received from devices can be presented for analysis as graph or table reports. So actually, let me share my screen so you will see how it actually look like, what it look like. We have a few independent system deployments or instances. In particular, production and demo deployments are worth mentioning. Demo deployment, you see the web UI of the demo deployment on the screen now. There are no functional differences between these instances. Containers on streets are connected to the production deployment, and we provide access to the demo deployment to our potential clients and partners so they can get a grasp on the system. And let's finally look at what's in there. I'm signing in. And the main workspace of the system is the map, where a location of connected devices are represented with markers. Since we are using demo deployment currently, in our case, all those markers correspond to virtual smart bins and waste sorting stations spread all over the world. That allows us to see the system at scale and evaluate its potential. Symbols you see currently are groups of bins and stations. Grouping is used when, with current map scale, it's impossible to display individual markers of bins and stations. But as soon as we click on the groups, we can actually get to the level, to the zoom level where individual markers will be seen. So for instance here, we employ color coding of markers by primary parameter, fullness level, from green to red. So basically, green means fullness level is less than 50%. Yellow one means the fullness is from 50 to 74%. Orange means that the fullness is from 75 to up to 89. And then 19 plus is represented by a red color. So as you've just seen, we were able to actually filter the bins we currently see by using the fullness filter, and we get back to this topic a bit later. Now I want to tell more about the markers themselves. So the digit in the center of a marker means the fullness level of a bin in percent. If it's just a single bin, like this marker closer to the bottom right corner. But if you're talking about the waste separation station, the digit in the center corresponds to the container so the station is comprised from several containers, and the one with the most fullness level, that level is represented on the marker of a station. So stations are represented by the square markers, which are actually separated into a few segments of different colors, as you can see. And colors aren't arbitrary. Such colors allow the operator to navigate UI offhand. Green means everything is fine, and red, it's basically about time to make a decision. And upon selecting a card, upon a marker, a card appears to the left with detailed information about the bin, including depletion statistics, which you can see here, and readings from the primary sensors. This whole block is all about. It is the primary sensors, not all of them, and as well as some additional features for this device. In case of waste separation station, we are able to navigate the cards of the all containers in the station. But for the satellite bin, so we have a master bin in a station and a satellite bin. And satellite bins are contain less electronics and overall a bit simpler than the master bin. And we have only the fullness sensor from fullness level sensor reading from such kind of devices. So we can filter devices on map using various criteria. We already seen how we can do that by the fullness level. So let's just pick all the bins that have above the 90% of fullness, which are guaranteed to be full. And we also can filter by waste type. So the mix means just all types of garbage in a single bin, and we have also some few predefined types that can be used. As you can see, standalone bins, which not much in current filter set, just disappear from the map. And in case of waste separation stations, part of these markers become gray, what means that this particular part of the station doesn't correspond to the filter set. So different filter types get combined, and we only see devices that match all of them. And filtering is not only useful for situation analysis, like what's going on, but it's also indispensable for creation of trash pickup routes. Our solution enables collection and tracking of data necessary to save waste collection transportation costs. Now let's just move from the sunny Dammam closer to where we are located, to Moscow, because it will be easier for us to actually see the route creation in action by that way. So let's try to pick from this area the bins with the most fullness levels, like 90 plus. And we can still see that in this demo simulation, there are pretty a lot of them actually. So we just can zoom in, and only bins that we actually see will be used to create trash pickup routes. And obviously, the disposal of garbage from devices that don't have a fullness level above the 90%, it would be basically inefficient because there's just not that full. So to plan a route, we are going to the route planning. That the button I've just clicked was in the bottom right corner. As you can see, the filter that I've used, 90% was applied here, and all the bins that we was picked on the map just get carried here. The page itself consists of the 3 blocks. So the bins section, the driver sections, we have two. Let's imagine that we have 2 drivers actually. We're ready to pick up those bins. And the last section is the sectors. So it's about the assigning sectors to drivers. And sector is a named group of devices which are suitable to be dumped together efficiently. An assignment of a sector adds bin to the corresponding group. Upon creating a route, so when we are creating a route, we assign sectors rather than individual devices to our drivers, and that makes the task of assigning devices to different drivers much easier for the operator. Now let's see what it looks like from a driver's perspective. I'm going to switch between shared screen of my laptop and my Android phone for this one. So I'm not going to stop sharing my laptop now, and will share my screen of my phone. So I hope you all can see it. And we run our Binology application. Currently, I'm logged in here as this Binology and driver 1, as you can see. So this screen in particular, its purpose is to wait on a route to come. So basically, the driver just waits when he will get a task to actually pick up some beans. So let's get back to the SaaS software. Let's just pick the driver that was that we just saw on the mobile device, and all sectors are automatically assigned to him. And let's actually send routes. When we press Start Route, tasks are created and are sent to the mobile devices of the drivers. And let's switch back to the app and see what actually changed. As you can see, the first thing the driver gets the whole list of the devices he is about to pick up, and he presses Start Route. And what happens at that point is the application builds the route to actually pick up all of the devices. And when we press the Start Moving, we will get a route to the first bin. Let's just zoom out this a bit. And you can see that the driver got a route for the first point. Since we are just sitting tightly on one place, we are not going to actually move in here. But what we still can do, but that upon reaching this point, we can say something like, yeah, we unloaded this bin, but there was some issue like, I don't know, graffiti was on the bin. Sorry, was... So that way, driver can actually report what's going on in the field. And when we press to next route point, we will get the route to the next point of our route. So let's see what we can do in the SaaS with all of that. We have this section which is called Routes Journal, and we can see that the route we sent to the driver was started. We can get into details about it. We can see when it was started. We can see all the points that were sent, and we can also see results of what was going on. So basically, we see that the driver collected this one, and we see the comment that was supplied. Okay, let's get back to our map and talk about the other rich functionality of our SaaS software. It's the reports. It's possible to get some reports directly from bin details panel. So let's just select one and get to the probably main report. This is fullness report. Let's pick something more interesting like 30 days and see the graph representation of this report. And we also get this smart bin pre-selected because we got here from a card on the map. Because we're using demo deployment, report data is also virtual, but imitates real devices behavior. On this graph, it's easy to see waste accumulation and disposal cycles. So the garbage was accrued, and then it was disposed, and so on and so forth. Also, besides graph view, a typical report have a table view where all the same data is just represented as a table, and any such report can be exported to in the CSV or Excel form. Also, each smart bin has a set of weather station sensors enabling measurement of temperature, pressure, humidity, and air quality. So let's just quickly get through basically reports for the same bin. So it's the same bin, it just collects different types of data, and we see it as a different report. So for in this instance, it's like temperature at the different days for the past 30 days. Pretty similar will be like atmosphere pressure. So again, just data about the pressure of the environment air. And what I can also show you is that we also measure the air quality. So as AQI, maybe you're not all familiar with this term. So it basically stands for air quality index. And what I just clicked was a contextual help item that allows us to get to the biology, our knowledge base about the software. There's a lot of articles in here which can be used to understand any terms or some concepts that are not yet not much clear, or just you're not familiar with them. So as you can see, here's the legend of the air quality index that we are using. Yeah, that's probably what I wanted to show quickly in terms of reports. And this year we're going to enrich our product line with sensors for traditional waste containers used in housing and utility services. These are integrated with our software and will be displayed on the map similarly to smart bins. As you may notice, the system is designed in a way that enables operators to get results with minimal effort. And I know that there will have a lot of questions about the API integration, and we are interested in exploring this area, and we are open to work through such occasions on a case-by-case basis. And I think that's all for the presentation part for today. I thank you for attention, and let's proceed to the questions if you still have any not answered or in the chat. I see that Daniel posts. So we have another Daniel on the call, just so you know. In the participants list, I am the Daniel Ivanov, and the moderator Daniel is my colleague. Maybe if you like, we can just get back to any presentation part and just maybe pay a bit more attention to what we just got through, because I understand that it's pretty a lot of information to just grasp in one go. So yeah, just let us know. Yeah, I see that we have a question about the types of garbage. So basically, every device that we have or in the SaaS system can be assigned a type of waste type. And we have, as you seen, we have some predefined categories for that. And that allows you to easily track which devices collect which kind of garbage and plan your logistics accordingly. There's obviously not some magic that happens and device detects the waste type on its own. That's not the case. Yeah, I also see that we have a question about the role. So yeah, currently we have 3 types of roles in the system. So we have an admin user, an operator user, and the drivers. Basically, both admin and operator have access to the web part. And the major primary difference between those roles is about that the admin is actually responsible for managing all the different user accounts for a particular company. And drivers don't have access to the web UI at all. They just use the mobile application to get routes and do their part of the job. Yeah, so see that the Daniel just sent the link to the software page on our website. And if you like, you can just request a demo access from us. We create what we call the sandboxes for each individual user, so they can play with the system independently and just get accustomed to it and probably understand it better, and don't have any interference between different users. So just for you, you can do whatever you want in that sandbox. It's basically a safe space to play around with the system. Okay, I see that it looks like there's not many questions right now, but feel free to just reach to us and ask your questions if you get any after this this event. And again, thank you all for that you joined us today. Thank you for your attention and for interest in the biology. And I hope that this presentation was helpful to you, and maybe yeah, we can just continue with talking to you on the some different topic a bit later. So yeah, thank you everyone, and goodbye.